of the mathematical concept or the model, you may simply go for Googling on the internet, and the model derivation is everywhere in, say, Wikipedia, for instance. So anyway, the more important thing than deriving the model is that the implication of the model. What is the implication here? Say, for instance, we may catch that this model is sensitive to the constant growth rate, right? Since we have to assume the growth rate of the dividend. The only fixed, the only constant, the only thing we know that is the current dividend at time 0. So in year current, the only known variable is the current dividend. But since we have to consider the future dividends, you have to assume some growth rate here, right? So the model is sensitive to the growth rate assumption. So as I said already, what is your logic for that growth rate? So this is most the important part. Calculation or the derivation of the model is not that important. You may use computer program, or you can find the model on the internet. So this model is everywhere. The most important thing, the more important thing than the calculation or the derivation is the implication. Okay, so you have to train your logical thinking. And one simple scientific way to derive a growth rate is using the sustainable growth rate by multiplying its profitability. So this is the profitability times its reinvestment. So retention. Retention is, say, if a firm earns $100 in net income, say net income is $100. From that $100, firm may pay out to shareholders as a dividend. Dividend is 배당. So from net income of $100, firm may use this $100 to pay out dividends, or they either keep it, not paying out, just save it for the future investment. So you keep it in your firm, do not pay out. So it's called retention. So this is retain your earnings, save your earnings for future possible investment. Okay. So if a firm pay out $40 a dividend from $100, your payout ratio will be 40%. Okay. So payout ratio is from $100 of net income, you pay out $40, which is 40%. If you pay out $40 from $100, your retaining, your saving will be $60. So your retention rate will be 60%, which is 1 minus payout ratio. Okay. And the return on equity here, return on equity infers the profitability of the firm. So say on average, the firm, say, earns 10% on its invested equity capital. If you earn some money and retain 60% of the earnings for future reinvestment, you may earn 6% profit in the future, because say on the first year you earn $100, and you pay out $40 and you retain $60 to reinvest in the future. If your average profitability, if your average rate of return on equity is 10%, we can say that from this $60, you can make a 10% profit, which will be a $6. Okay, so you will earn you will earn additional, so this is the important part, you will earn additional $6 on that retain $60 in the future, which is 6%. So if we assume the return on not assuming the average return on equity is say 10% and the retention rate is 60%, it is reasonably or predict that the firm will make some additional 6% in the future. It means the earnings will grow at a 6%. Okay, so one simple way to assuming your future growth rate is using this formula, which is a sustainable growth rate formula. Okay, the constant dividend growth model assumes dividends grow at a constant rate, and the constant growth rate will continue for an infinite period. So the required rate of return should be greater than the infinite growth rate to apply the dividend discount model. So the dividend discount model is that the value of stock is the future dividend. The dividend in year 1, dividend in the next year will be, so you are assuming this dividend will grow at a constant growth rate divided by the cost of equity minus the growth rate. Since the numerator or denominator, 분모, denominator. Anyway, to apply this dividend discount model, the cost of equity should be greater than the growth rate. Okay, if the growth rate is greater than the required rate of return on the stock, will be the denominator will be a negative number. So in this case, the value of stock cannot be measured, right? So if you use negative number in the denominator, the value of the stock will be negative. This is impossible, right? Because value of the stock is always greater than 0. Okay, so another assumption is that the required rate of return should be greater than the infinite growth rate. Okay, there is a two-stage dividend discount model. So in this case, we may divide the period in 2 periods. First, the high growth stage, and second, the normal or the stable growth stage. Okay, so the infinite period of DDM, the dividend discount model, assumes constant growth rate for an infinite period. But in reality, abnormally, firms, say venture companies or startup firms, abnormally grow in first years, and in this case, they usually cannot be maintained indefinitely. Say startup firms so grow very highly in first stage, in first years of their operations, and this growth rate will start to decline in the future and be stabilized. So say maturity firms. So therefore, okay, oops, there is a typo. Therefore, temporary conditions of high growth cannot be valued using a dividend discount model. In this case, two-stage models can be applied for firms with supernormal growth. Okay, to reflect those supernormal growths in the model, we should combine the models to evaluate the years of a supernormal growth stage and then use the constant dividend growth model to compute the remaining years at a sustainable rate. Okay, say let's draw a timeline here. Okay, say in the first 2 years, say there is a high growth rate, say 20% here, and the growth rate will decline to 3% in the infinite period of time. In this case, you may estimate the value of the stock by adding the discounted value, the present value of the dividend at year 1 and the dividend in year 2 by dividing the numbers by 1 plus required rate of return, plus you use a dividend discount model, a constant dividend discount model to estimate the terminal value from year 2 to infinite. Okay, so you use a discounted cash flow, say dividend constant growth model as a future dividend divided by cost of equity minus a growth rate. So in this case, you're applying the constant growth model at time 2. Okay, this is when you're applying this model at time 0, at current. But since you have to apply this model from here, so the value of stock at time 2 is equal to the future dividend, which is the dividend at year 3 divided by R minus G. So if you apply this constant growth model, you will estimate the value at time 2. So this is the value at time 2. So once more, you have to discount it by, so this value divided by 1 plus required rate. Since this is the value at time 2, you have to divide it at time 2. Okay. Okay. From this here, please practice. Say this is a practice problem. So at home or with your group members, try to estimate, try to calculate this problem. Okay. Of course, at the offline class next week, I will show you how to calculate this estimation. But before that, please practice by your own self. Okay. To get used to it. Okay. So thank you for listening. Let's assume this part from next week. Okay. All right. See you next week.